Thank you for having me. It's great to see everybody here. Hopefully you're having fun. I find it fitting that the name of my talk is The Last Mile as Code, and you are on the last mile of today. So I know I'm the only thing standing between you and whatever fun stuff is happening this afternoon. So I'll hopefully end with a bang. But yeah, my name's Joe. Started a company named Pulumi here in Seattle, actually, almost 10 years ago. Can't believe it. And I have a confession to make. And we'll see if this works. There we go. I love code. I've loved code for a very long time, since I was very young. I think my formative years at Microsoft, I would literally pore over whatever source code I could find and try to learn whatever I could. I just absolutely loved the Windows NT source code, and by saying that, I probably date myself. But you know, Dave Cutler was very famous with like really good architect, really good comments in the code. I read the garbage collector code because I worked on the .NET team. It was a 1 million line single file called gc.cpp, written in C++, transpiled from Lisp. I kid you not. I think they've since refactored it and simplified it. But I love code. So how many people here love code as well? Love it. Well, we're not the only ones. It turns out agents love code too. And so what I'm going to talk about today is a little bit about how things that historically have not been coding problems can become coding problems, and therefore something that agents are really good at. And I'm going to talk a little bit more about my domain of expertise, which is infrastructure. It's actually true of information work. You know, even sales and marketing things can be represented as coding tasks, and then if you do that, agents are actually really good at solving these problems. So why are agents really good at code? Well, it's for a few reasons. One, code is everywhere. It's all over the internet. We have this beautiful thing called open source. We have GitHub. We have Stack Overflow. And one of the great things about code that's not true of many other information domains is that code is self-describing. We actually write documentation about the code. We write comments about what the code is doing, how it's doing it, and why it's doing it. And I just realized I forgot to set my timer so I don't go long. And so the agents have been trained on all of that information, right? So they know not just the symbolic, textual code, but they understand the semantic meaning and the purpose and all of the context around it. And the same isn't true of every domain. When you think of, medical, do doctors literally describe every single step they're taking as they're performing surgery so that, it can be learned on later on? Well, some of that information gets captured. A lot of it is not public on the internet. And so coding is way farther along than many other domains. And you can see that with the SWE-Bench numbers here, the software engineering benchmark. SWE-Bench verified, which has historically been the benchmark. Earlier this year, we sort of decided to switch to SWE-Bench Pro, which is a little bit more difficult and less in distribution in the models. It's almost unbelievable when I was putting together this talk. Less than 2 years ago, SWE-Bench verified the frontier models, the best models at the time, whether it was, GPT, XY, or, Claude Sonnet or Opus, was only 33 out of 100 in terms of the score. And SWE-Bench is basically just a collection of pull requests and issues closed and the test cases for them on the internet so that agents can be thrown at them and see if they can do general purpose coding tasks. And so they went from scoring 33 to these days in the mid-80s, and Anthropic's latest model that they haven't released yet, that may come out this year, Mythos, is actually in the mid-90s. And you can see SWE-Bench Pro, it just came out more recently, but it's gone from 40 to 70 just since February this year. And so what does it mean to go from 33 to mid-80s? Well, it means that agents, when they're doing coding work, make 75% fewer mistakes. And as we go from mid-80s to mid-90s, that will be another 40% reduction in the number of mistakes that they make. And as they make fewer mistakes, we as humans offload more work to them, and we can trust them, and they do very good at them. So agents are sort of natural coders for a bunch of good reasons. And people from time to ask, they say, hey, does code still matter? Does picking TypeScript versus Python matter? And I think there's actually even a talk about this topic tomorrow. And it does. Code is still there. Code is the reason that the agent is so good at vibe coding and increasingly lots of problem solving. You think of the old stack. We used to describe in text in a programming language what we wanted, and then a compiler would take those instructions and compile them down in a way that the computer could accomplish an outcome. Well, the new stack is one level of abstraction above that. We still describe in text. It just turns out it's human language text to an LLM that can then go write the code that then gets compiled into executable instructions by a machine. And so we're still writing text, and we're still getting computers to do things based on that. And just very quickly, so I, like everybody does, vibe coded an application. It's a little trailhead application. I figure a lot of folks might be coming from out of town. You might want to go on a hike in this beautiful Pacific Northwest in this beautiful weather. And so what this app does is effectively, you tell it a trail in the Pacific Northwest, and it generates some AI images that you might imagine you're going to see on your hike. And so doing this was pretty straightforward, and it took me, I want to say 15 minutes to get the initial one up and running, and then another 5 minutes of just back and forth to fix some of the styling of it. And lo and behold, I have something running on localhost that is a Trailhead application where I can pick one of the ones in here, or say Mount Rainier, for example. But these are just placeholder images. The problem is the application isn't deployed anywhere. It's just running local to my machine. And so we'll return to this later when we want to actually get it running so we can share it with our friends and colleagues and do more useful things with it. And it turns out, so the coding part was actually relatively easy. Now, coding is actually really difficult, as we saw with Kiro, getting the instructions right, the plan, the spec. It's not that programming is easy. Yes, the agent can do the rote work of writing a lot of the code, but we as humans still have to keep an eye on it, and we need to orchestrate systems and have teams of agents that are checking and doing code reviews, and we need to make sure that, I personally prod the thing as it goes rather than reading the code at the end, and staying on top of what the agents are doing and guiding them towards something with good taste and good aesthetics. And we as humans are still showing overall design oversight and judgment. So the code isn't actually the hard part. It's more the design and the way we interact with the agents. But then everything underneath it is still left as an exercise to the reader. What happens when I want to go deploy it to the cloud? What happens when I want to get an API key from over here and use it in my application and use it securely and make sure that my agent doesn't actually accidentally leak the token and cause a security problem? What about setting up all the security settings and IAM this and IAM that if I'm deploying to AWS or Azure? ClickOps, there's a lot of manual steps. What if I want to go sign up for MongoDB? Do I have to go log into the MongoDB console, click some buttons as a human, copy the token, give it to my agent? There's still a lot of manual glue in between. And that's what I'm calling the last mile. Interestingly, almost a year ago, actually it might have been a little over a year ago, Andrej Karpathy, who brilliant engineer in the space, worked on self-driving technology at Tesla, is now at Anthropic. He vibe coded an app very much like I did. He called it menu gen. You pointed at a menu, it generated images. He sort of said building a modern app was sort of like assembling IKEA furniture. And yep, you've got the bag of bolts over here and the boards over here, and all the building blocks are there, but it's still left as an exercise to the reader to put those things together. And even if you have a perfect blueprint, it's still a lot of work, and it's tedious work, and it's work you often have to step outside of the agentic loop to accomplish. And that stuff, as developers, my background, my entire career before jumping into the deep end with infrastructure with Pulumi was about developers. I worked on programming languages at Microsoft. I ran the compilers and languages teams, and I worked on operating systems, and then I came to the world of infrastructure. And for me, it was sort of like, wow, this is a mess. It's like mountains of YAML and piles of JSON and manual point-and-click instructions, and the thing that was missing was code. And the reason why I think people were okay with that is this last mile was often somebody else's problem. Especially, the bigger company you work in, the more it is somebody else's problem. Surely, if you're doing like a vibe-coded hobby app and you want to share it with your friends, it is your problem. But a lot of times, you have a platform team that's going to handle it. You have SREs that are kind of domain experts in what it means to deploy and manage applications. So why are all those things not things that agents are naturally good at? Well, if you look at what's in distribution, so there are two ways to get an agent to be good at something. It's either in distribution, which means it's in its training set, it's seen it somewhere on the internet before, private data, what have you, it's data it was trained on, or it's in context. You find some way to stuff it in the context window of a session, whether that's through giving it a web URL to crawl, a skill, CloudMD file, pasting it up, to begin with. Sort of the two ways to get it in there, of MCP servers and integrations with other systems, web calls. There's a lot of ways to get it in context. But out of the box, these frontier models have insane amounts of code in distribution. See the SWE-Bench data that I showed a few slides ago. So there's billions and billions and billions of lines of code, TypeScript, Python, and of course the in distribution mirrors the distribution of that code in the real world. So the most popular languages are higher in distribution, i.e. a lot of TypeScript. So here's the idea, is what if we took all the things that were in the last mile bucket, deploying stuff, managing, operating, gluing API keys together, signing up for accounts even. What if that were just something that could be accomplished with code and a terminal, those two things together? Now an agent can tackle more of that last mile. And so that's in the thin slice, IAC is the infrastructure part of it, that's infrastructure as code, the idea there, which is not new, by the way, this is kind of a happy accident 20 years later after we've invented IAC as a technology, that it turns out in this case, it's not always the case that what's good for humans is good for agents, but in this particular case, it actually is true that's what's good for humans, i.e. great programming language ergonomics, is actually good for agents that need to do infrastructure tasks. So this is just a little bit of an example. It's not the entire program for deploying that Trailhead app, but you can see here, this is just really TypeScript, right? Where we can do database schema migrations in the context of code. We can do, set up a Supabase edge function that's going to do some serverless stuff. We can publish our static website to an S3 bucket and export its auto-generated CDN domain name. All of the building blocks of the cloud are now programmable things that we have full access to, which is great as humans, of course, but this exposes the entire cloud as a programming model that agents can now operate against. Another analogy I like to draw is you wouldn't vibe code without Git, right? I mean, maybe if you're feeling particularly YOLO on a day, you might, but usually you want Git there as a safeguard in case the agent does the right thing, you want to recover your previous work, you get to Diff, you get to see exactly what it's doing when it's doing it, you can review its work, you can code review its work, you can have peer review of its work. Infrastructure as code is like Git Diff, but for your infrastructure. So you can see that, hey, I'm creating a new Supabase project, or spinning up a new edge function, or I'm scaling up the size of my edge function because I need to handle more load. And then once we have that as the foundation, we've now put that last mile in code space. The way I like to think of it is we took something that was represented in the realm of cloud infrastructure, we projected it into coding space. Now agents can operate against code, and then infrastructure as code is the thing that maps the activity in code space back down to the realm of infrastructure. So agents are able to accomplish outcomes in the realm of cloud infrastructure in the last mile by just working in code that they're already familiar with. Another interesting paper, this is from the Manus team, actually two years ago, actually. It's sort of a technique that a lot of people use, but not many people talk about. Actually, CodeAct uses this in its inner core. It actually uses TypeScript. Many agentic systems use Python. There's something called CodeAct, which is instead of raw tool calls, which is how we're taught to write agentic loops for agents, which is basically just, the LLM will decide, I need to call a tool. It emits a tool call. It gives you some JSON blob of the input parameters. The runtime executes the tool and then returns some untyped results that the agent makes sense of, which is problematic in many ways because those tool calls are generally not in distribution. They're not something that the agent has ever seen before. They're not very token conservative because they're just spewing tokens, and then all the output comes back as tokens, and so you can really pollute your context. By instead teaching the agent that instead of calling a tool, it writes Python or TypeScript, and then the agent runtime just evaluates that TypeScript or Python and then returns the results of that. It adds a layer of indirection where the LLM can do what it's good at, writing code, get results that are more token efficient because you can write Python code. So the Python code can do anything. It can grep through large bits of text. It can search for things. It can summarize things. You can do anything that code can do. And so this is a very interesting paper. I'd highly recommend it. It's a free PDF you can go download. Super interesting. But in it, they showed that by having agents work by doing CodeAct, and by the way, this is before a lot of the SWE-Bench lift. So if they redid their analysis now, I'd be really interested to see what they come up with. But it showed that they're 20% more effective at their job when they use this CodeAct technique. So I'm going to return to my demo, and we're going to ship it. And we're going to start, sorry. So we're going to use our infrastructure coding agent, Neo, and we're going to say, deploy my app to AWS. And this is live. It may not go well. I've been told that doing live AI demos on stage is a bad idea. So I actually do have something in the oven that I'm going to pull out in a second. But it's going to look at my project and try to understand. So what it's basically going to do is say, given my application, which is just a static website, what do I need to do? And in fact, I'm just going to switch to the video. So same thing, just pre-recorded and faster. So it starts by reading the code. And then it's going to say, hey, this is a Keynote demo, because I put that in the README. It's going to say, this is a React app. It's a static website. So I might as well use S3 and CloudFront. And Neo is our vertical infrastructure agent. You could do this with Claude Code, and we have a lot of open source skills that will teach other agents like Claude Code or CodeAct to be good at infrastructure. But we've taught it things like, to deploy a static website, which it inferred, you probably want to use S3 and CloudFront, and here's the right way to do it. And then it comes back and says, hey, here's a plan. So that's another key thing is infrastructure as code lets you preview changes before you do them. So you're not just going poking AWS, like running command line tools and like opening firewalls to the internet and things like that. You're actually human in the loop guardrails, being able to review what it's doing before it does it. And so this is kind of what I expected it to do. So it's going to go create all the project files, write the code. And again, notice this, most of what it's doing is writing code, which remember it's good at. It's running some ancillary commands as well, but mostly what it's doing is writing code. And then it does the preview, and it's like, yep, here are the things I'm going to create. S3 bucket, a bunch of bucket objects, CDN, all the stuff I expect. And so I'll go ahead and say, yep. Of course, there's auto-approve, very similar to YOLO mode in CodeAct, and dangerously bypass permissions in Cloud Code, which, by the way, I said is my default. So anyway, so it goes ahead and it deployed it, right? So I have that version right here. So this is deployed. Notice it's in AWS, so it's on cloudfront.net. I think there's Loop, I forget the name of it. There's actually a Cascadia trail, which I thought was particularly relevant to all of us. But we still haven't implemented the placeholder functionality. So it's running in the cloud, great. It's being served by a CDN. And by the way, even though I sped that up, it actually only took 4 minutes to actually deploy and spin up a CDN, which kind of blew my mind because I thought CloudWatch took like 20 minutes to deploy, so that part was actually pretty quick. I should probably cancel that. But let's go back here. And next, we're going to say, OK, that's great. We're hosting it on AWS. But now we want to add a Suppa-based database so that when I save my favorites, it's going to persist. And then I'm going to use edge functions for AI generation of the images. And I didn't even tell it to use OpenAI or Anthropic. It actually has secure access to all of my credentials. And so it's going to infer that, you have an OpenAI API key, so presumably that's where you want to do the AI generation. And it's going to chug away, very similar situation. And then it's going to come up with code. And we don't have to sit there and watch the whole thing get deployed, but here's the code that it came up with. You can see here it's really just here's for the database migrations. Here's where it says I want an edge function. You can see here, I get statement completion and everything. If I even care to look at the code, by the way, which I didn't initially. I just deployed it and I'm like, oh, it worked. That's great. But you can see the nice things in here, like when it comes to updating my, uploading all my S3 buckets while I'm just walking the distribution directory for my React app and just uploading, buckets for all of them and setting index. The nice thing is here, I didn't have to become an expert in all of these crazy low-level AWS building blocks. That's one of the amazing things about the cloud is you have infinite numbers of building blocks with infinite numbers of ways of configuring those building blocks. So actually having the agent figure that out for me is kind of amazing. And then you can see here, all of it got deployed. Actually got deployed very quickly, just 18 seconds, even though it took a while for it to write all the code. So we'll see if the demo gods shine favorably upon me. Let's do Mount Rainier. So this is the version that actually has Postgres hooked up so I can favorite trails and then the AI generation. And this is unfortunately not very fast, so we'll sit here in suspense. It is waiting on the OpenAI. I don't know, something about DALL-E is slower than I expected, but the images are pretty cool. At first, they were coming out like J.R.R. Tolkien images, and then I tweaked it, and then it was like, very dark and didn't quite look like the Pacific Northwest, so I had to work on the prompt a little bit. Come on. I could just blame Wi-Fi, I guess. I do have one here just in case it didn't work out. This is the Cascadia Marine Trail. So these are not actual real photos. These are what AI thinks I would encounter if I actually went on this hike. Which I'll admit, this looks like a hike to go on. Oh, there we go. Mount Rainier. I've actually seen the meadows like this, but I thought they were all purple flowers. I don't remember red and yellow. I've never been to Reflection Lake. Definitely have to make a stop there next time. So anyway, hopefully that's, you get the point there. And so, almost winding down here, something super interesting we've noticed is since the beginning of this year, we've gone from effectively 4% of all the deployments in our platform being performed by agents to now being 28% of deployments of cloud infrastructure being done by agents. So I don't know if that number is going to hit 100 next year, or 90, or 60, but it's clearly heading in a consistent direction. And so by turning infrastructure into a coding problem, the shipping part, the last mile part, is something all of us can do, which is great. It's empowering. We can own the end-to-end lifecycle. We can be full stack developers, the front end, the back end, and the infrastructure. And that's pretty exciting. It's TypeScript all the way down. And that's it for me. Thank you. Last mile's code. All the code is up here on GitHub. Closing photo. Cool. Thank you all. Really.